Chapter 5 Matter and Heat. Heat versus temperature. Heat is a relative amount of energy being transferred. So something like we give some energy to an entity and then it absorbs that heat or it absorbs that energy and gets hot. Then we say that heat is transferred. Heat capacity is how much energy an object can absorb. A temperature is proportional to the absolute amount of the energy present. So whenever a huge amount of energy is absorbed into the entity and it gets hot, then we say that it has high temperature. So it means higher the energy it absorbs, higher the heat it absorbs, the higher the temperature it has. So the temperature is a proportionality physical entity to heat. Now look at this experiment right here. You have the same size of ice cube, but in one cup you have a smaller cup. It's a smaller cup and the water inside of it is 100 degrees Celsius. It means it's a very boiling hot temperature water, but it is in a smaller cup. But you have a very big bucket of water and you have 10 degrees Celsius temperature water in it. So now we all know that the temperature of ice is 0 degrees Celsius. So for both the cup and the bucket full of water, both of them are higher temperature than the ice. Now let's pour these cups of water on these ice cubes. So on this first one right here, you're going to pour the water which is at 100 degrees Celsius. So obviously it is very hot, so it's going to melt some of the ice. So now look at how much left over right after we pour the water on it. Now come to the second ice cube where we have a bucket full of water and that has 10 degrees Celsius hot water. We're going to pour that water onto this ice cube right here and we see that this ice cube melted more than the ice cube right here, which was poured by the higher temperature water. So what you can observe from this experiment here is not only the temperature of the entity, but also how much is the quantity of it also matters. So the heat content with how much material it has in it also matters. That's what we need to observe from this experiment right here. It does matter how much the quantity it is and how high the temperature it is. The temperature is a physical quantity that gives rise to a sensation of hot or cold. If we say hot, it means we know that the temperature is high. If we say cold, the temperature is low. It's a physical quantity that gives these sensations. Thermometer is a tool that measures temperature. So most of the materials we know expand when we heat them up, contract when we cool them. So based on this concept, we have this thermometer right here. You can see this thermometer, which you would have seen many times. The red color one right here is the alcohol. So we give this red color just because we want to see the difference very obviously. That's it. So when you heat this one up, the material you have inside of this thermometer is very sensitive towards the changes in the temperature. So if there is any variation, it would quickly show it to our eyes. Okay, so let's say that we are heating it up. So now you can see that the red material in here expanded and now it's reaching to this one, this temperature right here. So now we can conclude from here that whenever you heat material up, it expands. So the same amount of material, but now it's taking more space. So it means it expanded as we increase the temperature. So this is the same physical law which is used in making these thermometers. Thermostats. Thermostats will have bimetallic strips. As the name indicates, bimetallic, it means two metals. Strips are used in turning the heating and cooling equipment on and off. So as we say, the bimetallic strips. So whenever we want to turn on the heater or turn off the heater, then these strips are used just like the switches. So we all know that we set the temperature whenever it's like in the summer we just set the temperature maybe like 72, and once the temperature gets higher than 72 it automatically turns on and then cools the room out, and whenever it reaches 72 it automatically shuts off. So that's what is the same principle. That's the principle is that's kind of work is done by this bimetallic step, the turning on turning off based on what temperature it is. See, these bimetallic strips use the principle of increasing the volume as a function of increase in temperature. As soon as the temperature is increased, those strips expand and turn the switch on. And once the temperature is cooled down, then they shrink down, making the system shut off automatically. So you can see this. This is how the strips are made. This is how the bimetallic strips are. They purposefully choose the strips in such a way that one of them is more sensitive to the heat and the other one is less expansive to the heat. So this gray one right here, light gray one right here is more expansive metal, and this dark gray one right here is less expansive to the metal. So whenever you heat it up, so obviously this is going to expand more, so it would expand more, so it would bend on this side. In the similar fashion, so it would connect the switch and it will make the circuit close, and the AC unit or heating unit turns on. And whenever it is very cold, obviously, this is going to shrink fast. So this is going to be smaller, and so obviously this is less sensitive. So it's going to show some change, but it's going to be not as obvious as this one right here. So the color of light, which is visible and invisible, given off by a black body, is a function of temperature. So as you can see in this chart right here, increase in temperature. So as the temperature, these are hotter colors, and these are less temperature colors right here. And as you go from this side to this side, the temperature of the colors increase. Temperature scales we use frequently. We use two temperature scales, for Fahrenheit scale and degree Celsius scale. And these are the some numbers I want you to remember. Freezing point temperature of water in degrees Celsius is 0 degrees Celsius, and the freezing point temperature of water in Fahrenheit is 32 degrees Fahrenheit. At 100 degrees Celsius, the water boils. The equivalent of it is 212 Fahrenheit. So when you look at the temperature scales, when we say temperatures like, one being starting with 0, one starting with 32 degrees Celsius, it doesn't mean the thermometers would be bigger or smaller. They will be exactly same size, but the markings will be a little bit different in Celsius and Fahrenheit scales. So when you look at this one, say let's say that it's 20 degrees Celsius right here. The height of this liquid right here would be exactly same in Fahrenheit too. Only thing that this would be showing somewhere around like 67 or something like that. Okay, and you can see that 100 degrees Celsius would be right here, and equivalent height would be 212 right here. So this is how the degrees Celsius and Fahrenheit scales will look like. Temperature conversion. Let's say that if we want to convert from one type to another type, which is from degrees Celsius to Fahrenheit and Fahrenheit to degrees Celsius, then we use these two formulas right here. So which is Tf is equals to 9 over 5 Tc plus 32 degrees Celsius, and Tc is 5 over 9 Tf minus 32 degrees Celsius. But Tf minus 32 is in the bracket, so you have to calculate this number first, and then whatever the number you get, you multiply by 5 over 9. Okay, in this case right here, you're going to multiply Tc with 9 over 5, and whatever the number you get, then you would be adding that to 32. So let's do an example based on the conversions. In 1983, the temperature of negative 89 degrees Celsius was measured at Russian research station in Antarctica. What is the Fahrenheit equivalent of this temperature? So now we need to convert this negative 89 degrees Celsius to Fahrenheit. So when we look at this 89 degrees Celsius. Let's go back to the earlier slide. That is, the degrees Celsius is given and we need to find out the answer in degree Fahrenheit. So I'll be choosing this formula right here because degree Celsius is given. So wherever this degree Celsius is there, that's where I'll be putting my number and going to solve for the Fahrenheit number. Okay, so you can say that 9/5, but I'm using the negative sign as it is because it is negative 89 degrees Celsius. So I have to use it along with this negative sign right here. So negative 89, so I did the math. So I got the answer of negative 160. So negative 160 plus this 32. So it would give me the equivalent of negative 89 degrees Celsius in Fahrenheit would be negative 128 degrees Fahrenheit. Thermal energy is the sum of kinetic energies of all particles that make up the body. Since heat is a form of energy, we still have the same units just as energy, that is joules. Any type of energy, whether it's electrical, mechanical, kinetic, potential, work, all these have the same units that are joules. Since heat is a form of energy, so we still have the unit which is joules. Heating an object. To heat up an object, we need to add energy. So in order for any object to get hot, we need to supply more energy. In order to raise the 1 kilogram of ice temperature, so the temperature of ice is 0 degrees Celsius. So if you want to increase the temperature of that ice by 1 degree Celsius, so that means you want to make the ice temperature to 1 degree Celsius, we need to supply 2.09 kilojoules of energy. And to raise the 1 kilogram of water temperature, so whatever the temperature the water is, that amount is 1 kilogram. And if you want to increase its temperature by 1 degree Celsius, let's say that the water is at 20 degrees Celsius and you want to make its temperature 21 degrees Celsius, then you need to add 4.2 kilojoules of energy. So when you look at these two things right here, I want you to observe that the amount is same and the temperature change is being same. But you can see that for ice, we are using 2.09 kilojoules of energy. But for water, we are using 4.2 kilojoules of energy. So it means the amount we are changing is varying with what material we are trying to heat up to. So the same thing which I'm going to show you in the picture, that is you have 1 kilogram of water and the water's temperature is 20 kilograms. And if you supply 4.2 kilojoules of energy, so the water same remains 100 degree, 1 kilogram, but the temperature of would be changing to 21. So exactly 4.2 kilojoules of energy if you supply, the temperature would just increase to 1 degree Celsius. So this specific amount of heat we are supplying to bring that 1 degree change, we call it a specific heat, and that is denoted by the letter C right here. Okay, so based on the specific heat, the Q is determined, which is how much is the heat energy is decided by this amount of specific heat. So how much amount you're changing it to, how much material you need to change the temperature, and how much is the specific heat per kilogram, and from which temperature to which temperature we need to change. So these three are the things you need to know to find out the heat energy. So now we look at this picture right here. That is you have water right here. If it is 1 kilogram, and if you want to bring 1 degree Celsius change, how much ever energy you use, if you give the same amount of energy to ice, the temperature of that ice, even though it is exactly same amount of mass, the temperature would have been 2 degrees Celsius. And the same amount of energy, if you give it to gold, same weight, which is 1 kilogram, but its temperature would have raised to 33 degrees Celsius. So here is the list which is given specific heat of various materials, and You can see that it is, the water is 4.2,